In this video, we are going to be simplifying rational expressions. Now, looking at these examples of rational expressions, we see that a rational expression is a fraction. And it's a fraction that contains algebraic expressions. So notice we have some x's in the numerator and or the denominator. Before we dive in, let's go ahead and remind ourselves how we simplify or reduce fractions without algebraic expressions in them. Now, one way we could simplify 10/12 is to break it down into factors such as 2 times 5 in the numerator and 2 times 6 in the denominator. Well, 2 divided by 2 is equal to 1, so we can cancel those 2's out, and we get 5/6. We'll be doing similar types of canceling with rational expressions. Now, we simplify rational expressions by factoring the numerator and denominator, and then cancel the common factors. So here there's not a whole lot of factoring to do in this rational expression, but we notice that we can factor out a 2 from both terms in the numerator. Now that 2 doesn't disappear. So 6x divided by 2 is 3x, and 4 divided by 2 equals 2. Now we still have this 2 in the denominator, and now we can cancel out these 2's because we've factored the numerator. So we end up with 3x plus 2. Just slightly more complicated on this next one. We can not only factor out a 2 from both terms in the numerator, we can also factor out an x from those two terms. So this time we'll factor out a 2x. And 16x squared divided by 2x, that equals 8x. Let's see, the 2x goes out front. We're undistributing 2x. And 16x squared divided by 2x equals 8x. And 10x divided by 2x is 5. So we have minus 5. And that's all over 4. Now we could actually rewrite that 4 as 2 times 2. And this 2x is really 2 times x. So 2 divided by 2 equals 1. We can cancel those out, leaving us with x times 8x minus 5 over 2. Okay, let's ramp it up a little bit here. In the numerator, we can factor out a 3y, but let's go ahead and make sure this leading term is positive. So let's make it a negative 3y that we're factoring out. So we're going to factor out a negative 3y from both terms in the numerator. Right, the negative 3y comes out front. And 21y squared divided by negative 3y equals 7y. And 3y divided by negative 3y equals negative 1. In the denominator, we can also factor out a negative 3y. Just coincidence there. Doesn't have to be the same as what we factor out in the numerator. So that negative 3y comes out in front. And when we divide negative 3y squared by negative 3y, we get y. And 15y divided by negative 3y, that's negative 5. So here, that whole negative 3y cancels out in the numerator and the denominator, leaving us with 7y minus 1 over y minus 5. On this rational expression, we have trinomials in the numerator and denominator. Now, it might be tempting to cancel out these b squareds. We are not allowed to do that, or we cannot do that, because we haven't factored yet. Let me pause just a moment to show you why not. Let's say this is a completely separate example. We had 2 plus 3 over 2. Now, if we simplify the numerator, we get 5 over 2, which equals 2.5. Now, if we had just canceled out those 2's, notice we don't get the correct answer. We get 3. So this is not how we do things. When we have terms separated by addition and subtraction signs, we cannot cancel out common factors. So let's go ahead and factor that numerator. Now, what we're going to try to do is factor it into two binomials. So let's try to think of two numbers that multiply to make negative 28 that have a sum of negative 3. Well, negative 7 times positive 4 equals negative 28, and when we add those, we get negative 3. So these two wing numbers will help us get our factors. We have x minus 7 and x plus 4. Remember, when we're factoring, we are unmultiplying. Let's factor the trinomial in the denominator now. We want two numbers that multiply to make 32, and those same two numbers have to add up to 12. Well, we know that 8 times 4 equals 32, and 8 plus 4 equals 12. So in the denominator, we have x plus 8 times x plus 4. And lo and behold, notice we now have a common factor in the numerator and the denominator. X plus 4 divided by x plus 4 equals 1, leaving us with x minus 7 over x plus 8. Well, we have addition and subtraction signs separating the x and the 7 and the x and the 8. So we are not allowed to cancel those x's. So we are done simplifying. All right, the polynomials in the numerator and the denominator look much more complicated here. We have a fifth power and a sixth power and other higher powers. Now, before we throw our hands up, let's take a look to see if we can factor out some kind of monomial factor here. So we're looking for a number and or some x's that we can factor out of all three terms in the numerator. And sure enough, all three terms are divisible by 5. So we will be factoring out a 5. And when we look at the x's, well, x to the 5th, x to the 4th, x to the 3rd, those are all divisible by x to the 3rd power. So let's factor out 5x to the 3rd power. At 5x to the 3rd power, that'll come out front in the numerator. 5x to the 5th power divided by 5x to the 3rd power, that equals x squared. We're just unmultiplying the three terms in the numerator by 5x cubed. All right, 25x to the 4th power divided by 5x to the 3rd power, that equals 5x. And 30x to the 3rd power divided by 5x to the 3rd power equals plain old 6. Might be some more factoring here, but let's go ahead and see if there's a monomial factor that we can factor out of the denominator. All right, we notice that we can divide each of those three terms by 2, so let's factor out a 2. And the smallest power of x is x to the 4th power, so we can certainly factor out x to the 4th power from all three of those terms also. So we're dividing out a 2x to the 4th power, and what's left over in there is x squared from the first term, negative 7x from the second term, and 10 from the third term. Now it looks like if these trinomials are factorable, it'll be much easier to find those factors. All right, in the numerator, so we're looking at this trinomial here. Let's find two numbers that multiply to make 6 that add up to 5. 2 times 3 equals 6, and 2 plus 3 equals 5. So that 2 and the 3 tell us that x plus 2 and x plus 3 are factors of this trinomial in the numerator. Let's turn our attention to the trinomial in the denominator. We're looking for two numbers that multiply to make 10, that have a sum of negative 7. Well, negative times negative equals a positive, and negative 5 minus 2 equals negative 7. So we have x minus 5 and x minus 2 in the denominator. Now we're a little disappointed here that none of these binomials cancel, but that's okay, we checked. And we can cancel some of these x's. We can divide out an x to the third power from both of those. So let's see, x to the third power divided by x to the third power is just 1. And x to the fourth power divided by x to the third power is just x to the first power, or just x. And let's go ahead and rewrite that. Feels like after all that, we should have been able to do more, but that's just how it works out sometimes. All right, these trinomials have a leading coefficient. We have a 3b squared in the numerator and 15b squared in the denominator. Let's see if we can factor out a common factor. Well, unfortunately, this 10 is not divisible by 3, so we can't factor out a 3 from the numerator. And it doesn't look like there's anything we can factor out of the denominator either. All right, no problem. We can try to factor these trinomials anyway. Now, when there's a coefficient in front of the x squared, if you're using the diamond method, we need to remember that we're going to be using the box afterwards, because the diamond will not tell us the factors. All right, to fill out the diamond, instead of putting a 3 in the top, we multiply that 3 times the coefficient of the b squared. So 3 times 3 is 9. So we're looking for two numbers that multiply to make 9 that have a sum of negative 10. Well, negative times negative is positive, and these two numbers do have a sum of negative 10. All right, now once again, these don't tell us our factors, but they will help us fill in the box. So let's start filling the box by putting the 3b squared in the top left corner, and the 3 in the bottom right corner. Now these two wing numbers, they tell us what go in the two empty boxes. So negative 9b and negative 1b. And now the dimensions of this generic rectangle here will be our factors. So to get 3b squared, we need to multiply 3b times b. Now notice we really need to put the 3b up here on the top, so it's lined up with the negative 9b. So we have 3b times b. That makes 3b squared. Well, b times negative 1 equals negative 1b. And 3b times negative 3 will equal negative 9b. And just double check, negative 3 times negative 1 does equal positive 3. So this is all working out nicely. Right, so the factors in the numerator are 3b minus 1 times b minus 3. All right, let's do that process one more time in the denominator here. So let's go ahead and multiply that coefficient of the b squared by negative 1. So we're looking for two numbers that multiply to make negative 15 that add up to negative 2. Let's see, the larger number needs to be negative, so we have negative 5 times 3. Those have a product of negative 15 and a sum of negative 2. We will use those wing numbers not as our factors, but to help us fill out the rectangle. All right, 15b squared goes in the top left corner. Negative 1 goes in the bottom right corner. These wing numbers go in the empty boxes, negative 5b and 3b. All right, we need to have two terms that multiply to make 15b squared. Well, it's looking like it's going to be 5b times 3b. Notice I lined up this 5b with these 5b's, and this 3b with this 3b. That'll be helpful. Let's see, 5b times a negative 1 equals negative 5b, and 3b times positive 1 equals positive 3b. And double check, negative 1 times positive 1 does equal negative 1. All right, we have our factors. 5b plus 1 times 3b minus 1. And this time, we notice we have some common factors that we can cancel out, leaving us with b minus 3 over 5b plus 1. There's nothing else to factor out, so we're done simplifying. I hope you have found these examples helpful for simplifying rational expressions. This is Mr. Ela, signing off.